All right, so let's keep things moving. Now we have the amazing and world-famous Hilary Mason.
Hi.
And we're going to have your presentation loaded up soon.
No, I'm plugging in, so you can keep talking for about 30 more seconds.
About how amazing you are? So world-famous, the best speaker ever.
That's a high bar.
Thank you.
Think this will work? All right. So hi, everybody. I'm Hilary. I think there's a lot of interesting innovation in data happening outside of Silicon Valley. It's happening here in New York. I'm a New Yorker, a native New Yorker, and a proud New Yorker. I'm currently employed as the data scientist in residence at Excel Partners, which is a VC firm, but don't worry, I don't actually make investments at all. Mostly, I just sort of talk to companies that have interesting or hard data problems. And those data problems tend to take two forms. They tend to be either highly technical, hours of whiteboarding infrastructure and coming up with ideas, and that's a lot of fun. Or they tend to be organizational. They tend to involve questions around, what do data scientists actually do? And so I thought it would be fun to try to write a talk around those organizational problems. So the talk I have prepared tonight is actually a meta talk. There's no code in it. It is about how you think about data science and what we actually do and can contribute. And if you would like to publicly shame me on Twitter, I'm H. Mason, though please be nice. And if you do want to talk about these things afterwards or are too shy to do that, you can find me at hilarymason.com. So when we think about building companies, they are themselves infrastructure, and data science is a piece of that. And yet, as data science has evolved and changed, even as professionals, the label data scientist is not entirely clear. And that means within a company, what data scientists do is not necessarily clear, and it's certainly not the same from company to company. Before I keep going, how many data scientists are in the room? How many people have that on their business card? What do the rest of you do? Do we have engineers in the room? Okay, we got some of those. We have people on the business side. All right, how about people starting their own companies? Okay, great. So we've got people across the spectrum here. A way that I've managed to articulate business to data scientists that has resonated pretty well, and this is the way I think about it, is that a company is a piece of infrastructure that you can deploy when you need to scale something beyond yourself. And that means that data science is a piece of that infrastructure, and yet we never really talk about where it sits or what it does. So when we think about building data teams, I like to think about it as teams of superheroes. And that's a good metaphor, because data scientists do a lot of things, but no individual data scientist has all of those skills and abilities, or at least they're not perfect at all of them. And so as you hire people, you should generally be trying to increase the capabilities of your team. And so we can look at that and say data scientists, in a very broad sense, do three things. They build mathematical models of some kind, they write code of some kind, and they generally can talk to other people about that stuff, or perhaps they have some business domain knowledge. This is at a very high level. Data scientist as a job does deserve its own job title, because these three things in one professional is new. But all of these three things have existed for a long time in their various forms. And when we say math, what does that actually mean? So at least in my practice of data science, the vast majority of the math we did was quite simple. The occasions when we actually got to use some fairly complicated math were rare, few and far between, and generally a lot of fun, but then we'd end up doing some simple math to approximate the interesting math we'd done and get on with our lives. But some folks live in a very different environment. And when we say code, there's a whole spectrum of code that data scientists write. So it might be the kind of, and I'm sorry for the academics in the room, but academic code, that is, it has to work, 1 out of the 10 times you try to run it, and I'm never going to run it again. There are obviously academics who write brilliant code. This is a broad generalization. It might mean code as in I have some messy data and I have to make sense of it. Maybe I'm doing it on the command line in Bash, or maybe I'm writing something to just convert it to CSV. Maybe it means you're actually a software engineer who knows something about those other two areas, and you actually know how to write production code, you know how to work in a team, you know how pull requests work, how version control works, how code review works, and all that fun stuff. Or maybe you're a machine learning engineer, which is a particular blend of math and code, but you're not writing the rest of it. Or maybe you're building the database. But in data science, it's a pretty wide definition. And then communication is really hard to define. Maybe that means you're making graphs, but even within graphs, there are two kinds of graphs and visualizations you can make. There are visualizations in the service of understanding your data. They're usually pretty ugly. And there's visualization in the service of communicating your data to a wide audience that is pretty graphs. And it goes far from there. So that's what a data scientist can do, essentially everything. And we need to do a better job of defining it. Harlan Harris and the team at the Data Community DC have actually done a survey and written up the results. So you can go check that out. And they sort of get data scientists to self-report on what they do. Through my observations, I just wanted to narrow it down to a couple of categories. Data scientists often provide business analytics. That is, they are using the data the business has to help make better business decisions. In the case of Bitly, where I worked for 4 years, that might be answering questions like, how many clicks did we get from Turkey? Because we're considering a deal with a Turkish publisher, and we want to understand that. It's generally something that should be in a dashboard available to everyone as soon as possible, but might not be, and so they might have to go through a human. That is data product. That is building product to either generate more data or taking the data you get from a product to improve the product itself. And I believe you'll hear about some of that stuff later from my awesome colleagues. And building data infrastructure, or data engineering, which is the engineering of systems where the design of the system itself is dependent on the nature of the data that flows through it, which is a really interesting skill set. Or perhaps it's doing research. So what do I mean by research? I'll get into that. So let's say you have a data team or you have a data scientist. I've talked to several companies who have that, and then they say, okay, what next? So where's my magic, I've got a data scientist, now I get my underpants and win the world thing, right? Well, it turns out it doesn't work that way. You actually have to have a method for thinking through what your data scientists are going to do. And that can come from anywhere. But I tend to group these things into three levels of futuristicness. That is, your data team can do immediate necessary analysis. And at the point most startups hire their first full-time data person, they've got a long list of this stuff. And so somebody can sit quite happily for several months just churning through reports and requests, but without really contributing to or building any building blocks that will be useful in the future. The second thing is more well-understood analysis. That is, we built a product, we've instrumented the product. Now we need to know first, how do we define what our engaged users look like, and how do we actually make users that are not looking like engaged users become engaged users? Solving problems where we don't need to invent anything new, but they are harder, longer-term projects. And the last bit is experimental analysis and building things that don't exist yet. That is, taking your data, taking your business, and looking for the opportunities that you have not yet accessed because you haven't combined those things in an interesting way. All of these things involve asking good questions. My answer at first was, where do questions come from? They can come from anywhere. At Bitly, we got some of our best questions through our tech support and our community team. They also come from giving people a lot of coffee and seeing what happens. Generally, look for places where intuition fails. That is, your company, your product, your data, you should have a good sense of what you would expect. And yet, when you see something in it that doesn't meet your expectations, that's probably an indication that there's something interesting going on there. If you see something that doesn't make absolute complete sense to you, ask why. That is, why is this graph going up, not down? Or, why are we getting fewer clicks from this source than another? And be open-minded to questions that can come from the least likely place. In fact, whenever I interviewed somebody for a job on the team, I like to ask them what the first few questions they would ask is. And once in a while, they actually came up with something we hadn't thought of yet. Right. So the last bit of my meta talk is something that I haven't actually discussed publicly before, but is something that I struggled with a lot in managing a data team that was contributing to engineering product and doing business analytics as well. But that is, given the long list of things you want to do, the long list of things you have to do, and this idea that everything you build should take you one step further towards the ability to build more new cool things, how do you possibly prioritize? And so for each question someone might ask, I will ask 4 questions. The first one is very straightforward. It is describe the thing you want to understand. Sometimes that's not trivial at first. The second one is how do we know when we've won? That is, what are our metrics for success for finding an answer to this question or finding an algorithm for this problem or building a product to solve this need? That makes sure that this will not continue forever and suck up a lot of resources when it's not that interesting. And if there are no error metrics that we are planning to use initially, we might be working on something like a recommendation algorithm, and the error metric for the first version is it looks good to me. You at least have to admit that in public in front of everybody else. And that public shame thing is a powerful motivator. The third question is, assuming we can solve this perfectly, what is the first thing we'll do with it? That makes sure it has immediate relevance to the product or the business or the system you're building, because there are a lot of super cool ideas that do not tie directly to the goals of your company. And this one makes sure that there is at least one obvious, good, compelling reason to put your time into this thing. If there's more, that's great, but you need at least one. The last question is, if everyone in the world uses this thing, what changes? So are we working on something that is going to be high impact? We don't want to spend our time on incremental improvements to things that are not actually going to change people's behavior. Now, an alternate version of this question that I ask sometimes, depending on who's in the group, is what is the most evil thing we can possibly do with this? And this is not because I am a fan of doing evil things, though I did actually consider writing an alternate talk on writing Twitter bots, which I may do at some point, and that's kind of evil. But because most of the people I've had the pleasure to work with are actually quite lawful good, and it's hard to get them to think outside the bounds of the product they're already thinking about. So if you ask this question, like if we put this thing in the hands of an evil dictator, what would they do with it? It's a way to get people to sort of brainstorm and come up with crazy ideas for it, some of which might actually be good. So if you do this, cool things happen. And can I get animated GIF in PowerPoint? I've never done that before. All right. So I'm going to take 10 seconds while I'm up here on stage to also pimp Data Gotham, which is a conference that happens in the fall. And the idea for the conference is to show off the interesting work in data in New York City across all industries. That is finance, healthcare, startups, big companies, whatever you happen to do. If there's an interesting data story, you should come tell it. The talks there are technically inclined, but not highly technical, because it's usually a story about how someone solved a problem with data. And there are plenty of events that happen during the year associated with Data Gotham as well. And if you sign up for the Data Gotham newsletter, it'll tell you about this meetup as well as a couple others. And that's all. So thank you very much. I'd love to hear what you think about this, because it's a fairly new articulation for me. So thanks.
Thanks, Hilary. Do you want to sit down and we'll take a few questions?
Okay.
Any wants to start? If you could start with your name and company, please.
Sure. I'm Alex Zoff, and I work at Next Big Sound. My question is about if you have a problem that has a data set and the product that comes out of analyzing this data set will only be useful if you find something interesting in the data set, like if you find a certain cluster or a certain set of clusters. How do you work with prioritizing those when you're not sure? Like, can you do sort of a rough draft, or how do you work with that?
Yeah, so practically, whenever I'm considering a problem like that, we might say, what's the quickest way we can explore this area to know that there's some value here or not? And so say you're going to cluster users and see if you can see some behavior. There's a bit of interesting work that goes into defining your distance metrics. So is that something that's then reusable for a later problem, right? So it's making sure that people don't go down rabbit holes and never come back with something valuable, but also leaving the freedom to explore something a little bit crazy. And in terms of the day-to-day management, I'd like to make sure everyone who I work with has both one sort of longer-term, more well-understood problem, and then one problem they can work on when they're really excited. That's a little bit, as you said, a little bit more speculative. And that keeps a good balance in the total team portfolio.
And there's one question over there.
Hi, Max from Bloomberg. So still talking about the prioritization problem. Being a data person, I'm curious if you've looked into formal methods like decision analysis and rejected them, or have you just not gone down that way?
No, I'm more of a hacker than a decision analyst. I've read a little bit about it, but much of what I've read was interpreted for a different kind of corporate structure than a startup environment. And so I haven't found anything that's very relevant to what I've worked on, but if you have a reference, I'd love to hear about it.
There's one over here.
I'm Claire from Skimbox. If you are building like a database product and the algorithm that ends up working best you really don't understand, is that okay? Like if you don't know how it's working, but it's just like, oh, it's working?
I don't think that's okay.
Okay.
That actually goes to the interpretability of your models. And again, I won't speak for the large companies or people who are working on very specific problems, but when you're generally building systems that in a startup environment, it's really important to understand why your system is doing the thing it's doing, or else it's going to change what it's doing, and you're going to be totally, impolite word goes there.
Hi. What are your thoughts on...
Name and company.
Fabian, I'm at Twitter. And what are your thoughts on the size of the company and in regards to how much research is being done versus how much project-driven, like product-driven work is being done within a team? And how do you split up a team in terms of pure data science versus more software engineering?
So that's a really interesting question, and in the companies I've worked with, it has a lot to do with the problem the company is solving and whether it's directly tied to their revenue. So I can speak about Bitly, where I worked for 4 years, and when I started at Bitly, there was a lot of data and absolutely no business, and so clearly a lot of resources went into research. In fact, even hiring me and someone else when the company was really tiny was a big investment in the data and building on top of the data. I have seen companies that successfully separate research and development as long as everyone still eats lunch together, but generally that doesn't seem to be a great approach, in that you eventually end up with a research department off in the corner publishing papers and a product that is over here, doing whatever the product does, and they don't really integrate effectively. And so how you build those relationships is not something I'm an expert in, but if you want to reference, reading the Idea Lab, which is the history of Bell Labs, was something that I found pretty inspiring.
Thanks very much for the talk. I like your paradigm, your approach. How do you avoid the problem? Oh, I'm sorry. I'm David from Paradox Consulting. How do you get around the problem of having data priests in a company where there are certain people who have access to the data and people can come to them for answers, but you want to democratize it more and give people tools so they can do some of the work themselves?
Okay, there are two approaches to this problem. One is the no assholes rule. So just don't work with those people. And the other is whenever somebody has to ask someone else for a piece of information to get their job done, it really makes everybody much less effective. So if you see people asking for the same kinds of information, there should be dashboards or a way that they can access it that's available to everyone in the company, and they should know how to use it. And so that's not always possible, especially very early on. And in some companies I've talked to where they only have a production database, and so you really have to be careful about what you ask of that. But it is definitely a goal to aspire to, where there should be an interface where people can get the answers to the questions they need to ask to get their jobs done in a way that does not involve them talking to anyone else.
Great. We have time for one last one.
Thanks. I'm Nick Peck from Bloomberg. Has asking that last question of what's the potential for evil ever stopped you from working on a project?
No, but we came up with some pretty creative ideas. Keep in mind, most of my work has been under the auspices of Bitly, which is looking at links about Kim Kardashian on the internet, and so there was not a huge potential for that to go wrong or be used in a way that we really didn't like. But asking that question did cause us to make certain business decisions that we otherwise might have made.
Okay, great. I think that's all the time we have. Thank you so much, Hilary.
Thanks, Matt.